Hello everyone, so let's solve the numerical from Calorimetry, ICSE grade 10 physics. So question is that a refrigerator converts 100 gram of water at 20 degrees Celsius to ice at minus 10 degrees Celsius in 73.5 minutes. Okay, so we have to calculate the average rate of heat extraction in watt, and we have given specific heat capacity of water and specific latent heat of ice and also specific heat capacity of ice. Okay, now let's see how to solve this problem. Okay, so first of all we will write whatever is given to us. So see, we have given mass of water which is 100 gram. So see, this small m equals to 100 gram. Okay, now the initial temperature of water is 20 degrees Celsius. So it is value of T1. Okay, now see the final temperature of water is minus 10 degrees Celsius. So this is not T2. This is the important point you need to understand. Okay, T1 is 20 degrees Celsius, but T2 is not minus 10 degrees Celsius. So what is T2? T2 is 0 degrees Celsius, and this minus 10 degrees Celsius is T3. Now why T2 we are going to write down? We will understand this. Okay, now sea water. What is this? This is specific heat capacity of water, which is 4.2 joule per gram per Kelvin. Then this is specific latent heat of fusion of ice, 336 joule per gram. And this is specific heat capacity of ice. Okay. Now time is also given 73.5 minute. Okay. So we will have to convert this time into second by multiplying 60. We will get 4410 second. Now, so in this question, total heat extraction will be completed in three stages: Q1, Q2, and Q3. Now let's see what are these three stages. Okay, so in first stage, what will happen? Heat will be extracted to cool water. Okay, so initially water was at 20 degrees Celsius, and in cooling, whatever heat will be extracted. Okay, so this is first stage of heat extraction. So from 20 degrees Celsius to 0 degrees Celsius. Okay, so we have here two different temperatures. It means we have to apply this formula Q equals to mc into del T, which is temperature difference. Okay, so del T is T1 minus T2. Now mass of water is 100 gram. Specific heat capacity of water is 4.2. T1 initial temperature of water 20. Okay, when water will be cooled, so it will be at 0 degrees Celsius, so 20 minus 0. So after calculating this, we will get 8400 joule. This is the heat extracted during cooling of water from 20 degree to 0 degrees Celsius. Now water is cooled and it is at 0 degrees Celsius. Now we know that there is conversion of this liquid state of water to solid state of ice, and this process will happen at same temperature. Okay, so heat to convert water at 0 degrees Celsius to ice at 0 degrees Celsius. It means heat extracted during conversion of water from liquid state to solid state at the same temperature 0 degrees Celsius. Now you can understand there are no different temperatures. This temperature is same, constant. So we cannot apply this formula. So which formula we will apply? We will apply formula of Q equals to mLF. Q is heat extraction, M is mass of water, and LF is what? It is specific latent heat of fusion of ice, which is given in question 336. So put these values: mass 100 and 336 latent heat of fusion. So you will get heat extraction during conversion, during change in state, which is 33,600 joule. Now, water is converted into ice, but in question it is clear what they have written. A refrigerator converts 100 gram of water at 20 degrees Celsius to ice at minus 10 degrees Celsius. So the final temperature is minus 10 degrees Celsius. So there will be third stage also of heat extraction. Okay, now ice is at 0 degrees Celsius. The temperature will decrease to minus 10 degrees Celsius. So when the temperature from 0 to minus 10 degrees Celsius, there will also be heat extraction. So that heat extraction will be calculated by mc T2 minus T3. Why? Because there are two different temperatures. So whenever you are having different temperatures, use this formula. And if you are having constant temperature when will it happen? whenever there is change in state. Okay, so q3 equals to n specific heat capacity of ice also given in question, t2 minus t3. So what is t2? 0 degrees celsius. What is t3? 10 degrees celsius. Put these values, you will get 2100 joule. Okay, now you have total heat extraction. You have value of q1, q2 and q3. You can put all these three values in this formula, q equals to q1 plus q2 plus q3. So of total heat extraction during, okay, from temperature 20 degrees Celsius to minus 10 degrees Celsius is 44,100 joule. Okay, now they are asking in question, calculate the average rate of heat extraction in watt. Okay, so what you have to calculate? Average rate of heat extraction. Whenever it is written a rate means per unit time. Okay, rate of what? Heat extraction. Heat is represented by Q. It means you have to calculate Q upon T. And what is this Q upon T? This is representing power. Okay, and you can see in watt, and we know what is the unit of power. So in this way you can identify formula, which formula you have to apply. So heat extraction in watt, P equals to Q upon T. Now you have total heat extracted, which is Q 44,100 joule. Put this value in formula. T is 4,410 seconds. So you can see 0 will be calculated, can cancel with this 0. Now 441 ones are 441 and 441 tens are 4,410. So you got 10 watt. So in this way you can solve this problem. So this problem is not difficult, but how to solve this problem, that is important. How to understand formulas, which formula you have to apply where. Okay, so whenever you will read question properly, you will understand and you will do practice, so it will be easy for you to solve any type of numerical. Thanks for watching, and if you want to see more solution of ICSE grade 10 physics, so you can like, subscribe and share. Thank you so much.